Hello friends, in this video I'll be talking about learning vector quantization or LVQ. I suggest you, if you have not watched my video on KSOFM, that is coherent self-organizing feature map, you go to that video once and then you come on to this, because these videos, they are almost similar. So let us understand the training algorithm first. Step 0 is to initialize the reference vectors. From given set of training vectors, take first m, that is the number of clusters, training vectors, and use them as the weight vectors. Remaining vectors can be used for training. Step 1 is to calculate the Euclidean distance for I equal to 1 to n, j equal to 1 to m, where j equal to 1 to n represents the number of clusters, I equal to 1 to n represents the number of input vectors. That is, you have to calculate the square of the Euclidean distance between every input vector and the cluster unit. For example, if we have 4 input vectors and 2 clusters, then we have to calculate the distance of x1 with y1 and y2, and whichever distance is lower, that particular cluster will be called as the winning cluster. Now find the winning unit index j when d of j is minimum. Now update weight on winning unit using the following conditions. If t is equal to j, that is, if target value is equal to the winning cluster unit, then you need to apply weight updation like wi equal to wi old plus alpha times x minus wi old. And if it is not equal to, if the target value is not equal to the winning cluster unit, then you have to apply weight updation like wi new equal to wi old minus alpha times x minus wi old. That is, here it is plus and here it is minus. So this is the architecture for LVQ. These are the input vectors and these are the clusters with which they are connected. Now let us see the question. Construct an LVQ net with 5 vectors assigned to 2 classes. Given vectors along with the classes are as shown. So we have been given 5 vectors, and corresponding to them we have been given classes as 1, 2, 2, 1, 1. Since their number of classes given in the question is 2, therefore first 2 vectors, that is these 2 vectors, will be used as the initial weight vectors and remaining 3 vectors as the input vectors. So the architecture will look something like this. Since we have 2 classes, y1 and y2, and x1, x2, x3, x4 will be the input vectors which are connected with the cluster 1 with the weights 0, 0, 1, 1, and with y2 they are connected with 1, 0, 0, 0. So initial weight matrix will get like 0, 0, 1, 1, 1, 0, 0, 0, where 0, 0, 1, 1 represents the distance between the x1, x2, x3, x4 and y1, and 1, 0, 0, 0 represents the distance between x1, x2, x3, x4 and y2. So let us see for the first input vector, that is x equal to 0, 0, 0, 1 with target value 2. Now since here we'll say we have 3 input vectors, these 3 input vectors we have. So for the first input vector we'll get 0, 0, 0, 1. Target value is to calculate the Euclidean distance. So how do we calculate the Euclidean distance? 0 minus 0 whole square plus 0 minus 0 whole square plus 1 minus 0 whole square plus 1 minus 1 whole square. This is the Euclidean distance between the cluster 1 and x1. So we'll get d1 as 1. Similarly, d2 will get something like 1 minus 0 whole square plus 0 minus 0 whole square plus 0 minus 0 whole square plus 0 minus 1 whole square. So we'll get d2 as 2. Since d of 1 is smaller, therefore winning index is 1. Now see, but here the target class is 2. Target class is 2 and winning index is 1. So therefore these 2 values are not equal. So we'll have a minus sign here. Wj new equal to wj old minus alpha times x minus wj old. So we'll apply weight updation with the first cluster. So w11 new equal to w11 old minus alpha x1 minus w11 old, 0 minus 0.1, 0 minus 0 equal to 0. Similarly, see w21 new equal to 0, w31 new equal to 1.1, w41 new equal to 1. Therefore we get the updated weight matrix like 0, 0, 1.1, 1, and 1, 0, 0, 0 will remain the same as we have not applied weight updation with the cluster 2. Let us see for the second input vector. In the second input vector, d1 comes out to be 4.21, d2 comes out to be 1. So winning index is d1. Here also it is not equal to the target value. That is, the winning index is not equal to target value. Here also we will have minus sign. And updated weight matrix will look something like 0, 0, 1.11, 1 minus 0.1, 0, 0. And let us see for the third input vector. Here d1 comes out to be 2.01 and d2 comes out to be 3.21. That is, d1 is calculated as 0.0 minus 0, 0 minus 1, 1.1 minus 1 minus 0, and d2 is calculated as 1 minus 0 minus 0.1 minus 1 plus 0 minus 1 plus 0 minus 0. So you'll get values like this, and here the winning cluster is 1. Here the target value comes out to be equal to the winning index. So we'll apply weight updation with a plus sign here. Wj new equal to Wj old plus alpha times x minus Wj old, and here are the final values which we'll get. 0, 0.1, 1.09, 0.9. So this is the final weight matrix that we'll get for this question. So friends, if you like the video, please like, subscribe and share. Thank you.